Part 15 of Refurbishing a Vintage Model Steamboat, and this covers making the radio control servo mounting in order to control the rudder, the regulator, the reversing lever and the emergency gas shutoff valve. When figuring out the best way to do the job, it's down to the individual. I looked at the job and saw that halfway down the stern section of the boat was a really strong piece of metal going across the hull, and this piece of metal was perfect for the rear mounting of the servo tray. For the front mounting of the servo tray, I had to reinforce the other cross member, and I did this with a piece of plywood and plenty of epoxy resin. When building model aircraft, I've had to make my own servo tray, and I've also made them for model steamboats in the past, so it's very straightforward. It's just a case of getting everything to line up. The difference on this servo tray is it's double-sided. These are the underneath servos for the regulator and the reversing mechanism, and then there are also two servos on the top, one for the rudder and one for the little gas valve. I find making things like this very easy and not a challenge at all, inasmuch as that I can look at something and see the finished product before I make it. The servo tray started off as a flat piece of 4mm ply, and I sat a servo on the 4mm ply and drew round it with a felt tip pen, and once I'd got the servo positions I cut them out with the bandsaw. And finally, after a bit of messing about, it looks like this. This again is the underside view you can see. I'm actually going to use screws to hold these blocks in position to make sure they can never drop off. The whole thing's held together with cyanoacrylate adhesive, so it's quite strong. In some servo tray installations they can be permanently bonded in place, but this servo tray needs to be removable, in case I need to change a servo or in case I need to make any adjustments, not to mention fitting the servos in the first place with the linkages to the controls. The servo tray is held in the boat at one end by a couple of M4 captive nuts, and a couple of countersunk M4 bolts going all the way through the deck cross member into the servo tray will hold it firmly in position. At the other end of the servo tray, it's just a case of two pieces of plywood to locate it on the cross member that's further down in the hull. Time now to look at the servos. They come out of the packet just as a servo with no mounting grommets and no arm. You get a selection of arms, and these are some arms that I have that are extra long and very strong. The arm simply fits over the spline shaft and is held in place with a small screw. I don't know at this stage which of these holes I'll be using for the actuating rod, so I need to find which hole in the arm will give me the maximum travel without stressing out the servo. Stressing out the servo could be a problem. If the leverage is too great on the servo arm by using the outermost hole, then the servo could fail. If any viewers have noticed that my thumbnail is painted black, there is a reason for this, and it's definitely not a fashion statement. It's because I was painting this servo tray with it held in my hand, and I painted my thumbnail. As simple as that, nothing weird. In this clip I'm checking the position of the servo arm and making sure that it's in the middle of the travel of the servo, so that when the radio control system is installed and I turn everything on, the arm will go to 90 degrees to the servo, like this. It's always best to check this, because if you don't and you put everything together and then turn on the radio gear and the arm tries to go in the opposite direction, something may break. These small servos come with a bag of rubber grommets, and here I'm fitting the rubber grommets to the servo. Why, may you ask? Does it really need them? Yes, it does. The reason for the grommets is to prevent vibration affecting the servo's electronics, or shaking the electronic circuit from together. This is especially important in model aircraft and model cars, where the high-revving, single-cylinder glow engines can produce a lot of high-frequency vibration, very undesirable in an electronic circuit. After these rubber grommets have been fitted to the servo, that is not enough. It's no good just putting a screw through the grommet and tightening it down, because that would destroy the shock-absorbing properties of the grommet itself. What goes in the middle is a small brass eyelet. I have two things to say about these brass eyelets, and one of them is do not under any circumstances drop them on the floor. If you do that, you'll probably lose the eyelet forever. And the other reason is make sure you put them in like this, with the larger part of the eyelet underneath the grommet. And the reason for doing it this way, and most people do it wrong, is that the larger surface area of the eyelet cannot be pressed into the wood when the screw is finally tightened. There are many types of servo arms, or servo horns as they're known, and this one is just a double one, but I don't want the double effect. I only need the arm on one side of the servo. The problem with this is you end up with a nasty sharp cut-off part. Can you see it's very square and very nasty? And I like it to be round, like the original. So what I do is put it on my linisher or belt sander and grind it to a round profile. But unfortunately it's very raggy. So what I do is I use a cigarette lighter to just make it not raggy anymore. You've got to be careful with this. Do not use too much heat and don't burn your fingers, and don't be in any rush to touch it, because A, it's hot, and B, it's soft, so you will burn your finger and leave a fingerprint in the end of the servo arm. And for any pyromaniacs watching, here is me doing the same thing to another of the servo arms. As you can see, I'm not putting a lot of heat on it, but just to illustrate the point, I am touching it with my finger, leaving a nice fingerprint on it. There are many types of servo arm, and this is another type. This has got 4 arms on it. So you simply chop off 3 of the arms, but make sure you leave arm number 1 as the one you want, because then the splines will allow you to get at 90 degrees to the servo. Try it yourself, you'll see what I mean. And once again, the workshop cigarette lighter is put to good use to make the edge of the arm more acceptable to the eye. This of course is not essential, but if a job's worth doing, it's worth doing well. And here are all the servos ready to go into the servo tray. And you can see the small gas valve to the left. This is the emergency gas shut-off valve, and it's quite important to have this. Otherwise, if the water boils dry in the boiler, then the boat emulates a Viking funeral, which would not be good on such a nice old boat. And finally, in this episode about radio control, it's most essential, I feel, to use one of these. This is a Volt watch. This device is plugged into a spare socket on the receiver, and it gives a good indication of the state of the battery. Flying a model plane or sailing a model boat or any other radio control model with this on the caution or low setting is dicing with death, well, death of the model, and if it's a model aircraft, anyone who gets in the way of the model. These units are very useful in the setup stage to see how much current the servo is drawing. The more current that the servo is drawing, particularly if the servo is stalled, the further down the display will go even with a healthy battery. They're also switchable for 4.8 or 6 volt operation. I haven't decided which battery to use on this boat yet. That's it for now. I'll leave you with a shot of the Volt watch and my beautifully painted thumb. Thanks for watching, and I hope you found it useful.